So you're probably feeling pretty comfortable with the diagram of the heart, but let me just go ahead and label a few things just to make sure we're all on the same page. So blood flows from the right atrium to the right ventricle, and then goes to the lungs, and then the left atrium to the left ventricle. So that's usually the flow of blood. And one of the things that keeps the blood flowing in the right direction, we know, is the valves. And two of the valves, I'm actually going to name, give you new names, something slightly different from what we have been referring to them by. These are the atrioventricular valves. And you can take a guess as to which ones I'm referring to. Atrioventricular valves are the two valves between the atria and the ventricles. So one will be the tricuspid valve and the other is the mitral valve. And just to orient us, this is the tricuspid, the T, and this is our mitral, our M. And the atrioventricular valves, these two valves, if you look at them, they're both kind of facing downwards. And one of the things that you might be wondering is, well, how is it that they aren't just flopping back and forth? And these valves in particular have a very interesting strategy, and that is that they actually are tethered, they're tethered to the walls. So they're held down here like that, and they have on the other end of those tethers a little muscle there. Now, this makes perfect sense if you think about it, because the ventricles are very strong, right? We know the ventricles are really, really strong. And so if the ventricles are squeezing, there's a good chance that that blood's going to shoot up in any direction it can go, right? It's going to go back perhaps through the mitral valve if it can go there, or it'll go through that tricuspid valve if it can go there. But the reason that it won't is that these papillary muscles are basically kind of sending out little lifelines, these chordae tendineae lifelines, to keep the valve from flipping backwards. So these chordae tendineae, these cords, are important for that reason, right? They're keeping the valve from flipping backwards. So these are all chordae tendineae, and these are all the papillary muscles. And these are particularly important, then, we can tell, for when you're trying to make sure that the ventricles don't screw up the valves. And now let's say that by accident, let's say our ventricle was just too strong, too powerful. Let's say that it broke one of these cords. Let's say it broke this one right here. And that's because our ventricle was just forcing too much blood back, and it just snapped the cord. What would happen? Well, this would basically kind of start flipping back and forth. It would flip this way and this way. And then on the next heartbeat, blood would start going the wrong direction, right? Because this valve is not able to keep that nice tight seal. And so blood would basically kind of go this way when it wasn't supposed to. And all of a sudden, our flow of blood is now going in the wrong direction. So the chordae tendineae and the papillary muscles do a really, really important job in preventing that from happening. So now let's move our attention to another area. Let's focus on this right here, which is the ventricular septum. And you can think of septum as basically a wall. Interventricular septum. And this interventricular septum, the one thing I want to point out, which is maybe fairly obvious when you look at it, you might think, well, why did you even have to say it? That's pretty obvious. This area is really thin, and this area is really thick by comparison, right? So the two areas are not equal in size. This is much thicker. And the reason I wanted to bring that up is because this first area in blue is called the membranous part, literally like a membrane, membranous. And the bottom, the red part, is the muscular part. This is the strong muscular part. So you have two different areas in that interventricular septum, the wall between the ventricles. And one of the interesting things about the membranous part in particular is that a lot of babies are born with holes in that membranous part. So when I say a lot, I don't mean the majority of babies by any means, but one of the most common defects, if there is going to be a defect, would be that you would actually have a communication between these two, so that blood can actually, again, flow from a place that it's not supposed to go, the left ventricle, into a place it shouldn't be going, the right ventricle. So blood can actually flow through those holes, and that is a problem. So that is called a VSD, and actually you might hear that term at some point, so I just wanted to point out where that happens, VSD. And while I'm writing VSD, you can take a stab at guessing what it might stand for. Ventricular, and S is septal. Again, septal just means wall, and D is defect. So a VSD is common, most common, in that membranous part, more so than that muscular part. Now, let's move on again to one final thing I want to point out, which is I want to zoom in on the wall. So here in a gray box, I'm going to kind of highlight what's going on in this wall and how many layers there are in this wall. Let me draw out a little rectangle to correspond to that little rectangle I drew on the heart itself. So there are three layers to the heart muscle. And actually I'm going to go through all three layers, and we'll start from the inside and work our way out. So on the inside you have what's called the endocardium. And I'm actually going to draw the endocardium kind of all the way around here. It goes all the way around the valve. So now you've already learned that the valves now have endocardium. It goes around the ventricle, and as I showed you in the beginning, also around the atrium, and it goes all the way up and covers both the right and left side. The endocardium is very, very similar in many ways to the inner lining of the blood vessels, actually. So it's a really thin layer, it's not a very thick layer, and it's the layer that all the red blood cells are kind of bumping up against. So when the red blood cells are entering the chambers of the heart, the part that they're going to see is going to be the endocardium. So this is what it looks like, and this is that green layer all the way around that I've drawn now. So if I was to draw it kind of in a blown up version, it might look like this, right? And it's a few cell layers thick, and like I said, on the inside you have some red blood cells bumping along. So maybe this is one red blood cell and this is maybe another one, and they would bump into that endocardium. Now if you go a little bit deeper to the endocardium, what do you get to next? Well, next you get to myocardium, and that would be, let's say, the chunk, the biggest chunk of our wall, and that would look something like this. And that myocardium you can kind of appreciate just without even having me point it out, because it's the most common part of this entire thing, right? So this is our myocardium. And let me go back and actually label the endocardium as well. This is the endocardium. And on the other side, endocardium, and actually just notice that the words are all pretty similar. Myo means muscle. And actually, while I'm on myocardium, let me just point out one more thing. The myocardium is where all of the contractile muscle is going to be, right? So that's where a lot of the work is being done. And that's also where a lot of the energy is being used up. So when the heart needs oxygen, it's usually the myocardium, because that's the part that's doing all of the work. Okay, now on the other side of the myocardium, what do we have on the outside? Well, we have a layer called the pericardium, and let me try to draw that in for you. Pericardium, something like this, kind of a thin layer. And the interesting thing about pericardium is that there's actually two layers to it. So there's actually something like this, where you have two layers, an inner layer and an outer layer, and between the two layers you have literally a gap. There's a gap right there. And in that gap you might have a little bit of fluid, but it's not actually cells. I guess that's the biggest point. It's not actually cells, it's more just a little bit of fluid that hangs out there. So this whole thing is called the pericardium. Now, you may be wondering, how in the world do you get a layer that has a gap within it? So let me actually try to show you what happens in a fetus. So let's say you have a little fetus heart, tiny little heart like this, and it gets a little bit bigger like this, and then it finally gets into an adult heart, something like that. So this would be the adult heart, right? Well, at the same time that the heart is growing, you actually also have a sac, almost like a little balloon, right? And this balloon actually begins to envelope the heart. So this growing heart kind of grows right into the balloon. And so this balloon kind of starts going around it like that. And you get something like this. And then eventually, as the heart gets really big, you get something like this. You basically have this kind of inner layer of the balloon that's pancaked out. It doesn't even look like a balloon anymore. It's very flat. And then it kind of folds back on itself like that. And it comes all the way around. And now you can see why, even though it's continuous, I mean, it's not like it breaks. It is continuous here. It's continuous there. You can see how if you actually just were to look at one chunk of it, like we're looking at right here, you could see how it would actually look like a pancake. And so on our heart, it literally would be something like this, like a very thin kind of pancake. And I'm not doing a very, very good job making it look thin, but you can imagine what it is that it could look like if I was to zoom in on it. Basically something like that, where you have two layers that are basically just kind of turned in on themselves. And both layers put together are called your pericardium. Now, there are actually separate names for the two layers. So for example, the layer that's kind of hugging up against the heart, this layer that I'm drawing right now, this layer is called the visceral pericardium. So you call that the visceral pericardium. And the name visceral, this right here, would be visceral. And the reason it's called visceral is because viscera refers to organs. So that's called the visceral pericardium. And then this outer layer, the one I'm drawing now, is called the parietal pericardium. Parietal. And that's the layer that actually is on the outside. So let me label that as well. So that's this guy. That would be the parietal pericardium. So now you can actually see the layers of the heart, the endocardium, myocardium, and pericardium. And actually, just to throw you a curveball, because I'm pretty sure you can handle it, this visceral pericardium, another name for it, just because you might see it sometime, is the epicardium. Sometimes you might see the name epicardium. And don't get thrown off, it's really just the visceral pericardium. It's just the outermost layer of that heart before you get to the parietal layer.